In this class, we will study basics of probability. Topics to be covered are introduction, definitions of various entities of probability, probability in subjective and objective views, joint probability, conditional probability, multiplicative and additive rules of probability. Then we'll see some examples. Let's introduce probability. People use the term probability many times each day. For example, a physician says that a patient has a 50-50 chance of surviving a certain operation. Another physician may say that she is 95% certain that the patient has a particular disease. Let's see some definitions. If an event can occur in n mutually exclusive and equally likely ways, the probability of occurrence of one of the events A is P of A is equal to 1 divided by n. What's an experiment? Any planned process of data collection can be called as an experiment. What's a sample space? It's a group of unique, non-overlapping possible outcomes of an experiment. What's an event? One outcome in the sample space, a possible outcome of a random circumstance. What's a complement? An event opposite to the event of interest is called a complementary event. If A is an event, its complement is either written as A superscripted C or A bar. So the probability of complement is P of A subscripted, A superscripted C or P of A bar. Let's see an example. Consider a selection of a person for an employment out of one male and one female. The complement of male event is the female event. We can write P of male plus P of female is equal to 1. Or P of A plus P of A superscripted C is equal to 1. So now let's see some views of probability. Firstly, a subjective or qualitative view of probability. Probability is an estimate that reflects a person's opinion or best guess about whether an outcome will occur. Important in medicine. Based on symptoms, a physician forms a probability of a particular infection. Such an estimate can be changed with the results of diagnostic procedures. Let's see some objective views of probability. It's well known that the probability of flipping a fair coin and getting a tail is 0.5, based on the hypothesis of equal probability. The meaning may not be understood clearly in a single trial. The equally likely concept is more understood through the following. If the coin is flipped 10 times, is there a guarantee that exactly 5 tails will be observed. If there is guarantee, there is equally likely concept. If the coin is flipped 100 times, are there going to be 50 tails? With 1,000 flips, are there going to be 500 tails? As the number of flips becomes larger, the number of tails becomes closer to half mark. We can say that if the total number of experiments is 1, the number of tails becomes closer to 0.5, which is half of 1. It's a hypothesis because actual numbers can be only integers. We will say that under the condition of a very large number of experiments, if the number of experiments is 1, the hypothetical number of tails will be 0.5. So let's see an example, probability of male versus female birds. In the long run, relative frequency of males born in KSA is about 0.512. That is 512 boys born per 1,000 births. The following table provides the results of simulation. The proportion is far from 0.512 over the first few weeks, but in the long run settles down around 0.512. So what's this relative frequency concept? Assuming that an experiment can be repeated many times, and assuming that there are one or more outcomes that can result from each repetition, the probability of a given outcome is the number of times that outcome occurs divided by the total number of repetitions. This is an example of blood groups analyzed in males and females describes the relative frequency concept. Let's see what is conditional probability. It is the probability of an event on condition that certain criterion is satisfied. Let's see this through an example. Let's understand this through an example. Consider the distribution of resistances in a box as shown in the following table. So you see that number of 22 ohms resistance is 24 with the 10 resistances of 5% tolerance and 14 resistances of 10% tolerance. Then we have 47 ohms resistance, a total of 44. In this 28 are 5% tolerant and 16 or 10% tolerant. Then we have 100 ohms resistance of 32 number. In this, 24 resistances are of 5% tolerance and 8 resistances are of 10% tolerance. Now, if a resistance was selected from a box of resistances 22 ohms, 47 ohms, and 100 ohms randomly, and found to be a 22 ohms one, what is the probability that the resistance has 5% tolerance? here the condition is having 5% tolerance. Hence, the conditional probability of drawing 22 ohms is probability of 22 ohms under the condition of 5% tolerance is equal to 10 by 62. Now, what's the joint probability? It's the probability of occurrence of 2 or more events together. As an example, probability of being 22 ohms and 5% tolerance is probability of 22 ohms into probability of 22 ohms under condition of 5% tolerance. That comes to be 22 by 100 into 10 by 62 is 220 by 6,200, which can be further simplified. Let's see some properties of probability. The probability ranges between 0 and 1. If an outcome cannot occur, its probability is 0. If an outcome is sure, it has a probability of 1. The sum of probabilities of mutually exclusive outcomes is equal to 1. As an example here, drawing of 22 ohms, drawing of 47 ohms, and drawing of 100 ohms. These three events are mutually exclusive events. We can write the probability of 22 ohms plus probability of 47 ohms plus probability of 100 ohms is equal to 1. Let's see some rules of probability. First is a multiplication rule. If two events are independent, the multiplication rule is probability of A and B, that is joint probability of A and B is equal to probability of A into probability of B. If A and B are independent, conditional probability becomes simple probability, that is P of B under the condition of A is equal to P of B itself. Another multiplication rule is on dependence. Dependence and modified multiplication rule. If A and B are dependent on each other, P of A and B, the joint probability of A and B is equal to P of A into P of B under the condition of even A. If A and B are not independent, if A and B are not independent, P of B by A, that is P of even B on condition that P of even A is not equal to P of B. Next is additive rule. We will say two events as mutually exclusive, that is A and B are mutually exclusive if the occurrence of one event precludes the occurrence of the other event. That is, the occurrence of one event stops the occurrence of the other event. P of A or B is equal to P of A union B is equal to P of A plus P of B. As an example, the probability of being either 22 ohms or 47 ohms or 100 ohms when you draw a resistance from a box of these different resistances is